Hey guys, it's your boy coming at you with another spicy video. Sorry about the delay in uploads, I was kind of sick for the past few days. But in this video, we are going to take a look at pass 1 of the assembler in the C++ language. So first of all, let's get started. I'll just do a hash include and we'll do bits stdc++. So stdc++. This is just going to include every standard header file as well as standard library, so you don't have to remember whatever other libraries there are. If your examiner asks you that why you have not used IOStream here, just know that they got pretty small brain energy, okay, because this already includes all of the major libraries. And yeah, that's a dumb question, right? This is just a basic setup. Now we'll start by writing a structure called OP tab, which will contain our opcode class and the mnemonics. Now I'll just do a struct op tab and we'll define an operation stable over here 18, right? This is equal to, and now we'll start writing all of our statements, the statements which formulate the assembly language, right? So all the instructions. You'll just have to remember all of these. So I'll just go ahead and write those. Right, there is no such choice that you have over. There's no easy way to memorize these. So yeah, it is what it is, guys. So these are IS. We have we have 10 IS statements. Okay, so there are a total of 18, out of which 10 are instruction statements, and the rest are assembler directives or whatnot. After that, now we will write a get op function. So int, it will return an integer, and yeah, this will literally make us op because it will allow us to search for specific opcodes inside of the this thing, our operation table, where all the instructions are given. Let's do a for loop uh, for the entire length of the operation table, which is 18. If the name matches with S, which is a string, sorry, it should be a double. Yeah, my bad. Then we'll return, and if it is not found, we'll obviously return -1. We have to now get the condition ID as well. So we'll write a function called int get condition ID, right? We'll put a string as the argument over here, and this is basically used when a BC statement when a BC statement is encountered. Sorry for my spelling. In this we have 6 conditions. Over here we cannot use a switch case because switch case does not allow string comparisons, or else a switch case would be a much faster alternative here. Now we will move on and write another function which will help us to get our register IDs so that we can convert a reg to either 1 or 2 or 3, something which we can actually quantify. I mean, we will now declare like a structure for our symbol table. So I'll call it sim tab, and in this we'll have 3 entries. So first one will be, put it as string, no, it will be int number, string, it will be string, let's say name, so name of the symbol, and string address, so addr for address. Right now we'll just create a symbol table using this structure as well, so I'll just call it st. I'm just going to put this as 18 so that since OP table का भी length 18 है, it will be easy to remember, just one length for each and every character. Right, now coming down to symbol table, we need 2 functions for this. First is going to be a bool in st. What this is going to return is basically if the string given name of the symbol is present in the literal table or not, or the symbol table or not. So I'm just going to go through the entire length of the symbol table, and if it matches, then I'll return true, or else I'll return false. Right? And another function which we will be writing is going to be an int get st. So using this we can get the ID of the symbol which we are searching for. Condition is going to be the same, just that s is equal to name or not, and then we'll return over here I instead of returning true or false, and if we don't find it, we'll return -1 anyways. Now we've done these 2 functions for symbol table. We need to do these 2 for literal table as well. So I'll do lit tab. Right, this is a structure. Our literal table will have again the same entries. We're going to have a number, a name, and an address. Right, and we'll do a struct lit tab, and I'm going to name this LT with 18 entry ka capacity, and just we have to do the same thing that we did over here for symbol table for literal table as well. So let's just copy this. It's giving us an error, so I'll name this inLT and get LT along with changing this. Yeah, my mistake. I actually named this a string. This should be a string. Right, even here it should be a string. Now that this is out of the way, we'll create a pool table, because we need our pools as well, right? Whenever we encounter the LTORG statement or the literal origin statement, so that we can have literal pools in our program. So to do that, I'll create a structure first. Struct, we'll call it pool tab, right? And in pool tab, we'll have a int number as well as a string literal number. So one of them will be our pool number and one of them will be the literal number. Okay, so this will be, even end statements ke liye this will be, populated, because when we have end, at that time also we dump our literals if there are any which are new and have not been indexed properly. So I'll just quickly define this. Pool tab, we'll call it PT just like the others, give it a length of 18. So these are all the functions. You can pause the video and go through them if you want to. Okay, now we'll move on to the main function itself, where we'll do most of the processing. So main, now over here we'll have to first of all call ifstream and open our input file. So I'm going to use this fn object fn.open and just enter the name of your file. So for me it's input.txt. Then for our output stream we have IC for our intermediate code, ST and LT for literal table, right? IC dot, will go open. For my program over here, I'm going to be giving all of my output files the extension of .md or markdown. IC, so this is what I'm doing: IC.md, st.md, and lt.md. The reason for this is so that I can generate tables out of this output. You will see this at the end of the video, so make sure you watch till the end. We'll just declare a few variables and a bunch of counters. This is a symbol counter. This is our pool counter. This is our literal counter, LTCTR, and this is a new literal counter. Do we store stuff in a literal table when we either hit end or an LTORG function, LTORG statement, right? So until and unless we hit that, we'll store this in our NL counter, the count of these, and after that we'll kind of make this 0, and when we hit the end or LTORG, then that disparity will be eliminated. Also guys, my bad, this was supposed to be OF stream, not O stream. I forgot to give a semicolon. You know how it is, you know how it is. We all forget sometimes. Over here I'll run a for loop until the end of file character. So while it is not EOF, I'll run this for loop. So I'll basically read everything from the input file. And also I'll define a few strings, such as string opcode, label, operand 1 and operand 2. So all of these will actually take fetch values from the input file, which we will be doing something like this, f in, and then using this operator we will extract those values into the strings themselves. This will go like label, label extraction operator, opcode, op1 and op2. Also please note that this operator does not consider any sort of spaces or new lines. Okay, so if you have a new line or a blank space, you will have to do error handling logic for that on your own. I have dealt with it by adding a null character every time there's an argument missing. We'll use we'll get the ID of the opcode ID over here by giving in the opcode to this get op function, and just form the first line of our instruction, intermediate code. I forgot to add LC and the IC over here, right? Now we'll go ahead and define our intermediate code. This will be just the first part. Now we'll just handle all the assembler directors. So we'll do handling assemb, right? We'll start from start, the OP code start, where we are starting, pun intended. If the LC, if the operand 1 is not null, then the user has specified a location from where he wants to start. So we'll let the starting location counter, we'll set that to the given operand, and we'll update the intermediate code accordingly, and the LC of this particular instruction will be nothing, because for assembler directors we do not assign a location counter. So what we're doing in this EQU is that we will first put the LCS dash dash dash, then our IC will basically be null, okay, or not a number. It should be null over here. Now we'll just check whether the label is present in the symbol table or not. If it is not present, then we'll add it. So to add it, what we'll do is we'll do stctr dot number equals stctr plus 1. Okay, this will add it to a new entry. Will obviously name of the, and we'll assign the address as the address of the operand 1. Get st and we will do op1 dot address. That's pretty much it. Also, don't forget to increment the symbol counter or SCTR. Alright, moving on now, what we'll do is, if opcode is not equal to EQ but the label is not empty or none. Okay, so label is not equals null. What will happen over here is we can add this directly to a symbol table basically. Now, if our opcode is origin, what that means is someone is trying to change our LC, doing displacement of LC basically. Right, in this find function we are going to find the plus. So basically if the plus is not found, we'll get a string npos value out of it. So we can do string found. If it is not equal to string npos, that means that plus was basically found. So if plus was found, then we'll put op as plus, and if it is if there was no plus found, then we'll put op as minus by default. Although that is highly unlikely because the main use of origin function is to perform either addition or subtraction of LC. So that would be highly unusual and mostly an incorrect syntax as well. Now to separate what this get line does is it will take the string stream, that is SS, and it will split it about the operator. So जो ऑपरेटर का पहले वाला पार्ट रहेगा that will go into token 1, जो बाद वाला पार्ट रहेगा that will be left as it is in string stream SS. उसके बाद here we are using getLine again to extract the remaining part out after the plus symbol to put it in the SS. So this part is going to be in the SS using that statement, and see this is going to be through this. I'll add semicolons over here. I hope that makes sense. It's pretty straightforward too. There's nothing complicated about it. Just know that we are using string stream, and because of that we can use getLine to perform this sort of split operation, which would be very easy in Python. Now if the operator is plus, then we'll have to perform the addition of the given symbol, get st, and the ID or the name of the symbol which we'll get from token 1, the address of that with the numerical value of token 2. After doing that, we'll have to change our IC as well. IC will be updated with these values, and we'll do the same thing for minus as well. Just swap out the plus signs with the minus. Right, so now we have written our LTORG function. Not function, it's a code block. I'm sorry to call it a function. But over here we have a for loop which runs only for the newly added literals in the loop. In this loop we are adding new literals to the literal table and giving the address of the literal as the LC. So see, we are converting LC to string over here, and even over here the address of the literal table is the LC, and then we are incrementing it. This statement is just console formatting, after which we use the we will use like the pool counter now to increment the pool number, because after every LTORG statement a new pool of literals is created, right? And the NLCTR will be 0 now, and we'll go to the start of the loop. We'll have to implement the this logic goes as follows. We put this and then it's PCTR plus 1, and then the literal number we determine like this. So do L number and then dot L number. We first put a hash, then we convert the difference between LCTR and LCTR, this difference, and then iskan number. This is what is our literal number. This is how we write our LTORG block. Now we'll quickly move on to the end block. Okay guys, so in this end function, what we've basically done is that we've kept the LCS blank, we've appended as and we've appended the null intermediate code to the IC, because again this is an assembler directive and end doesn't really return any values or have any arguments. Also below here, if NLCTR is non-zero, we have just copy pasted the logic of LTORG over here, with the exception of that if else statement for console formatting. But the logic is pretty much the same. Since we are ending the program, we need to create like the final literal table ka pool. So I mean a new pool will be created at the end statement, and again we are updating the pool just like that. And if you want to, you can, for sanity say, you can put this as 0. After this the loop is going to be exited anyways, because after end nothing really runs, right? I hope that makes sense. Now we'll move on to the declarative statements. So the declarative statements we have is DC and DS. So we'll do DC, or if opcode is DS, right? In this, it's basically we are either declaring a constant or we're declaring space for a variable. So we'll do toString. The LC will be again the line counter for this, just because this is the place where we are declaring it, right? So the LC will be this line itself. Then if it is DS, right? So if we are declaring space, if opcode equals DS, sorry. So what basically is going to happen is the user will give us a size. Okay, they will provide a size of the given variable, how many locations to reserve for that. So what you have to do is LC plus equals STOI. So this will convert the operand 1 into an integer and add it to the LC, and then we'll have to do the same thing for IC as well. Do plus equals and then add the constant. So C comma plus OP for operand 1, OP1. Yeah, that's pretty much it. And then there'll be a nan or null over here. This will just make sure that no further arguments are present there. So just for, and that's the syntax. Then we'll take another string over here. This is for DC, by the way, where we are declaring a constant. So when we are having DC, we automatically increment it by just 1. So we'll do IC plus equals open bracket C for constant and then close the thing, right? Plus this will be our C. So here we are extracting the value of the operand, the actual constant value, and we'll put this over here, and we'll also increment the LC. So just incremented it by 1, that's all. Okay. Now after this we'll move on to imperative statements. So for imperative statements, the condition will be if op tab, so we'll go operation tab dot id. This will give us the ID of the current instruction that is being executed or read by the assembler. And if the class of this is is, so basically if it's a instruction statement. Now over here we're just doing some checks and measures to gauge what are the operands and such. So if our operand 2 is null and the operand 1 is null as well, right? So that probably means that our intermediate code will also be null, right? So our intermediate code in this case will be null / null with the inclusion of the opcode label and other parameters which we define at the start of the loop. And our LC will be again toString LC ++. If operand 1 is not null, right, then that would mean that operand 1 is a symbol and we'll have to add that operand to the symbol table. So we'll put his number, the number of the operand table, as symbol counter +1. Then we'll have to put the name as op1, and again we can't really give it an address yet because we have not encountered an LTORG statement, gotten to know the label of that particular operand yet. So that will be taken care of in the EQU sort of block above, right? Guys, now we will move on to the else part where both the operands are present, and one of the edge cases or cases of this could be where opcode is equal to BC. Else, so if it is not BC, that would mean that the first operand is going to be a register. So it's a statement like move R or move N or add, multiply, subtract, something like that. Now we'll try and find out about operand 2, right? So if operand 2 of 0 is equal to sign, that would basically mean that we have a literal on our hands, right? So operand 2 is a literal. So what do we do with the literal? We add the literal. So after, if it is a symbol, which is the else part of this, where we are right now we are checking the operand. If the operand has an equal to in the first character, we know that it's a literal because literals usually start with equal to and then colon with the values. Now, if it is not a literal, it has to be a symbol. So for the symbol, what we are doing is we're finding that symbol from the table over here, right? And from this table, what we are going to do is we are basically going to update that IC, and if it is not in the symbol table, then we'll add it to the symbol table, and after adding it, we will add that part to the intermediate code as well. Also, don't forget guys to increment your symbol counter. We'll just put the LC as LC++, and that's it guys. Like, this program is pretty much done now, right? We'll just what I've done below over here is I've just added the symbol name and the literal name, and I've printed these tables. So the loops run from I equals 0 to LCTR. Actually, I had recorded this while typing it, but due to some reason that footage got corrupt or something. Yeah, my apologies for that, but this is what this was like a very minor part that was left, so I thought I could re-record this part. Anyways, yeah, this is the pool table, this symbol table and literal table. I just added 2 cout statements, and after this what I will do is I'll go out and then /subscribe, which will give us this. So I'll just go over here and open the input.txt. So we have an LTORG over here and an end statement over here as well. So that's why there are two pools which are present, right? That's correct. Then in literals, we have 1, 2, and 3 literals over here. And even here we have 511, the 3 literals. So the our literal table is correct. And I've kind of cross-verified it with my previous result as well. What can happen with writing this code is because it's such a long code, uh, you can probably forget to, write the plus plus somewhere or decrement or increment the counter somewhere. So make sure that after every time that you are having, entering into the SCTR, you make sure you update it. Mostly errors which I had was this regarding this issue only. Show you the intermediate code. This is the intermediate code which we have received. Then this is our literal table. This is our symbol table. Now I'll exit this and I'll open this in VS Code. So now that this is open in VS Code, the reason why I have put all of these files as markdown is because in VS Code you can actually format these into very beautiful tables. So this is our intermediate code file, right? Uh, what I'll do is I'll do like some basic formatting on it manually also. Basic formatting. Now what I did was I pressed Control plus Shift, and using that you can select like multiple lines at once. So using that you can like insert this special character over there, they are bitwise और जैसा दिखता है वो. I have done like just wrapped all of this. We have 1, 2, 3, 4 columns. So we'll need 1, 2, 3. So I have just added like these dash lines. These will indicate that this the line above it is a table header. Correct. So I'll do LC. This will be our IS or instruction. This will be our operand 1 and this will be operand 2. So I have an extension which formats it for me. Now if you go to the preview, sorry, yeah. See, this is how it looks. It's very neat and clean. You can, easily view it from afar. There's character inconsistencies because I actually gave it a capital L and a small l by mistake while typing. Okay. Now our program won't do that. Right. That's pretty much it, guys, for this video. If you like the video, please hit like and smash subscribe. This video took around 6 to 7 hours to film. It was a real challenge, especially one day before the exam. So I hope you appreciate that and smash that like button. See you in the next video, guys. All the best.